Welcome to data structure course. Hello student, I am Swapnil Chaudhary. Today we are going to see another topic of this unit, that is file handling. File handling. Okay. In this session we are going to see basically what are the types of file. Then we are going to see file organization. Then we are going to see file operation. Okay, so basic file operations like read, write, open, and that all. Now let's see the introduction. The files are most visible and most valuable feature of any computer system to its users. Files provide a mechanism for long-term storage of data. They remain to exist even if computer is switched off. Files are stored in the concentric circular track of a floppy or hard disk. So the first question is what is a file? What is a file? A file can be treated as a stream of bytes. A stream of bytes. Very simple. Or collection of bytes. The size of file expressed in terms of number or bytes in a file. Okay, the size of a files is expressed in terms of number of bytes in a file. Okay, the size of a file is expressed in terms of number of bytes in a file. Very simple, in a file. Okay, like if I draw the representation of bytes, so this is what byte 0, byte 1, so on, that is byte n minus 1, like this. Okay, so a file of size n bytes. Okay, file of size n bytes. Okay, now we are going to see the types of file. Now we are going to see the types of file. Okay, the first type is the basic type is text file, and second type of file is a binary file. Binary file. Okay, so these are two basic types of file. So let's see the first type, that is text file. Okay, a text file contains visible character. Basically, a text visible characters. Okay. We can see the contents of file on a monitor or text its printout or edit it using any text editor. Okay, so we can see the content of file on monitor or take its print, or we can edit using any type of text editor. Okay, so basically a text file contains visible character. If you see the example of text file, example is like a file containing stack program. Okay, a file containing stack program. Another example, a file containing a letter. Okay, a file containing textbook. Okay, so this is what the example of text file. So basically a text file consists of a collection of alphabets, digits, punctuations, or symbols, space between two words or two character, that spaces, tabs. Okay, a character, basically a character is stored in file by its ASCII value. Okay, so whatever characters we are storing in a file by its ASCII value, by its ASCII value. For example, if we stored a text file like A is equal to B plus C minus 943. Okay, so this is what we are going to store in a file. So what is that characters? So we are going to see character and their ASCII values. Okay, first, so character like A, which ASCII value is like is ASCII value 41H, and then we put some space here. So I am writing here space, then the space ASCII value is 20H. Then we put equal to sign. So equal to ASCII value is like 3DH. Okay, then again we put some space. So again space value 20H. Then we put B with ASCII value is like 42H. Then we put plus sign, that is 2BH. Okay, then we put C, that is 43, 41, 42. Okay, 43H. And then we put minus sign whose ASCII value is 2DH. Okay, and then 9, that is 39H. These are predefined value. Okay, so then 4 for 4, that is 34H. Then 3, that is 33H. Okay, so these are what ASCII values for this character. So this ASCII value is stored in a file. Okay, so it is stored is like, suppose if you have the file, and it is stored like 41h 20h. 20h means that is space, 41h means a, this is space, then this is space, then what we stored, that is equal to, okay, so equal to is 3dh, this is equal to signs ASCII value, and then 20h, again it is just what, space, then b, that is 42h, okay, then plus sign, that is 2bh, this is plus sign, then 43h, that is c, then 2dh, that is minus sign, and then 39h, that is 9, then 34h, that is 4, and the last character is 33h, that is 3. Okay, so in this way we are going to store this text file in the form of ASCII in a file, text value in a form of ASCII in a file. Okay, so this is what all about the how we stored our text file in a computer hard disk in the form of ASCII value. Now another form of another type of file is what, binary file. Binary file. Okay, the first one is what, text file, and another one is what, binary file. A byte consists of 8 bit. Basically we know that a byte consists of 8 bits. Okay, so we can have total 256, that is 2 raised to 8 combination of 8 bit, combination of 8 bits. So the byte contains 8 bits. Okay, so we can have 2 raised to 56, that is 2 raised to 8 combination of 8 bits, and an ASCII is a 7-bit code. Okay, 7-bit code representation, and represented in 8 bits. Basically ASCII is a 7-bit code represented in a 8 bits. Okay, this 7-bit code represent in a 8 bits. So ASCII has total 128, that is 2 raised to 7 codes. 2 raised to 7 codes. Out of them, first 32 has a last code or control character, and they are not visible. Okay, first 32 are control character that are not visible. Thus, the byte may contains a value that may either not be a valid ASCII code or it cannot be displayed. Okay, so basically if you ask for example, if you look at for example of binary file, that is like an executable file, that is an executable file, that is suppose if you write if you wrote a code for stack, or you stack and create its exe file. Okay, stack.exe, or you can say the object file. Okay, like stack.obj. Okay, so we can further understand the difference between the text file and binary file for knowing how the value of variable can be stored in them. For example, suppose x is a short integer variable. X is a short integer variable. Okay, it contains number 125. It contains a number 125, that is x is equal to 125. Internally, x will be contain the binary representation of 125, like 125's representation is like 0 1 1 1 1 1 0 1 0 1 1. Okay, so this is what a binary representation of 125. Okay, so storing x in a text file is like storing this x in a text file is like, that is byte 0, byte 1 and byte 2. Okay, sorry. Okay, so ASCII of 1, so basically we are storing 125, so ASCII of 1 is what? 31h. ASCII of 2, that is 32h, and ASCII of 5, that is 35h. Okay, these are what? ASCII of 1. Okay, this is ASCII of 2 and this is ASCII of 5. Okay, so storing 125 in a text form needs 3 bytes. So storing 125 in a text form needs 3 bytes. Basically it needs 3 bytes. Okay, and storing that x in a binary file is like very simple. Byte 0. So we are simply here put this 8-bit representation of in a single byte, that is 0 1 1 1 1 1 0 1. So this is what a binary number. This is what binary of 125. Very simple. So we can say that storing 125 in binary form needs only 1 byte. Okay, needs only 1 byte. Okay, it needs only 1 byte. So this is what a difference, a small difference. If you are storing the text file, it took 3 bytes, but if you stored in a binary form, it will take only 1 byte. So this is what a difference between the binary and text file. So now we are going to see a small comparison between the text file and binary file. Okay. So first let's see the text file. Now we are going to see small comparison. So first one is the for text file. Okay. So first thing is what? A text file contain ASCII value of text stored in it. So basically text file use ASCII value to store it. Okay, to store the value of text, it use ASCII value. Okay, the second thing is what? A text file can be seen on monitor. We can see seen on a text file can be seen on monitor, or it can be edited by any text editor. You can be edited using by, it can be edited using some or any text editor. Okay, and third thing, it is a easy to handle, as its contents are visible. Okay, it is easy to handle as contents are content okay, are visible. Okay, then like if text file is used as an input data file, then there will be additional overhead in converting integer numbers and floating point numbers and its equivalent internal representation. Okay, if text file is used as an input data file, then there will be additional overhead like converting integer numbers and floating point numbers and its equivalent internal representation. Okay, fifth thing you can say, an integer or real number requires more storage area when stored in a text format. Okay, an integer or real numbers requires more storage area when stored in a text format. So this is what regarding the text file. Now we are going to see some facts related to binary file, like small comparison. Binary file can be used for storing of text, graphics, images or sound data. Means basically binary file can be used for storing text, graphics, images or sound data. Second point, integer or real number require less storage area when stored in a binary file. Okay, integer or real number requires less storage area when stored in a binary forms. If binary file is used as input data file, then there will not be any overhead in converting integer numbers and real numbers to its equivalent internal representation. Okay, binary file is a more compact. See, next point is what? Binary file is a more compact and it takes less storage area as compared to text file. Okay, we already seen a small example of that binary file. Okay, where it takes, see, this is the text file, it takes 3 bytes and binary file takes 1 bytes only. Okay, so binary file is a more compact and takes less storage area. Okay, next point, a binary file can not be created with the help of text editor and hence it is difficult to handle. Okay, the most important point is what? Binary file cannot be created with the help of text editor, any text editor, hence it is difficult to handle. Okay, it is difficult to handle. And contents of binary cannot be seen directly on monitor. Basically, contents of binary cannot be seen on directly on monitor. Okay, since it is in the form of binary, zeros and one forms. Okay, so this is what a small comparison between binary and text file. Now in next lecture we are going to see the sequential and random access of files and their differences, physical storage media of file organization. Basically we are going to see file organization. So basically we organize file in sequential, relative, direct, index file and index files, index sequential file and index file. Then we are going to see some basic operations on file. Okay, that's it for today. Thank you very much for watching. Have a good day.